everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation from z equal to x plus y plus f of x y by eliminating the arbitrary function f. We are given an equation or a relation z equal to x plus y plus f of x y, and we are asked to form a partial differential equation by eliminating this f. Let's see. Given z equal to x plus y plus f of xy, consider as some equation number 1. Now let's partially differentiate it with respect to x. Partially differentiating 1 with respect to x. Just apply dou by dou x on both sides of 1, or do directly. You can skip this step. This gives us dou z by dou x equal to partial derivative of first term plus partial derivative of second term plus partial derivative of third term. Here we are partially differentiating with respect to x, so we'll treat y as constant. Okay, since we have a notation dou z by dou x equal to p, so let's replace it by p. We'll get p equal to partial derivative of x with respect to x is 1 plus partial derivative of constant with respect to x is 0 plus partial derivative of f of xy is f dash of xy into inner derivative, that is dou by dou x of xy. This gives us p equal to 1 plus f dash of xy into, here y is treated as constant, right? So we can write this as y into partial derivative of x, right? This gives us p equal to 1 plus f dash of xy into y into partial derivative of x with respect to x is 1. Y into 1 is 1. Sorry, y into 1 is y, which gives us p equal to 1 plus f dash of xy, y into 1 is y. Or we can write this as p minus 1. Just bring this 1 to LHS, you'll get p minus 1 equal to y into f dash of xy. Consider as some equation number 2, and the given equation is considered as equation number 1, right? So we got p minus 1 equal to y into f dash of xy. Now let's partially differentiate it with respect to y. Partially differentiating 1 with respect to y. Just apply dou by dou y on both sides of 1. Right? Since we are partially differentiating with respect to y, so we'll treat x as constant here. This gives us dou z by dou y equal to dou by dou y of first term plus dou by dou y of second term. See, it's not necessary to write these two steps. You can just skip it out and do directly. Since we have a notation dou z by dou y equal to q, so let's replace it by q. We'll get q equal to partial derivative of a constant with respect to y is 0 plus partial derivative of y with respect to y is 1 plus partial derivative of f of xy is f dash of xy into inner derivative, that is dou by dou y of xy. Here x is constant, so we can write this as x into dou by dou y of y. This gives us q equal to 1 plus f dash of xy into x into dou by dou y of y, right? Q equal to 1 plus f dash of xy into x into partial derivative of y with respect to y is 1. x into 1 is x. Now bring this 1 to LHS, you'll get q minus 1 equal to x into f dash of xy. Consider as equation number 3. Now observe 2 and 3. In both the equations we have f dash of xy. So let's eliminate f dash of xy from these two equations using 2 by 3. Which gives us LHS of 2 by LHS of 3 equal to RHS of 2 by RHS of 3. Right? This gives us P. Yeah, here f dash of xy gets cancelled and you'll get P minus 1 by Q minus 1 equal to y by x. Now make a cross multiplication and simplify it. X into P minus 1 equal to y into y times Q minus 1, which gives us Px minus x equal to Qy minus y. Now write the terms that involving Q and P or P and Q in LHS, and write the terms that does not involve P and Q in RHS. So you'll get Px, just bring this here and take this to RHS, you'll get Px minus Qy equal to x minus y. Just the required partial differential equation. Okay, therefore Px minus Qy equal to x minus y is the required partial differential equation. Which completes the problem. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.